I'm here today to talk to you about purifying TypeScript. But before we start, a little intro about myself. So, as I said, my name is Tim. I'm an engineering lead at BCG DV. As Reg said, I'm originally from Australia, currently living in Berlin at the moment. And so the reason I decided to kind of give this talk is we use a lot of functional programming languages at BCG DV, but I've never actually used it in conjunction with TypeScript. So the initial thinking was, is this a good idea? How easy is it? Does it work well? Is it worthwhile? So what are we trying to get out of today? So we're trying to understand how to apply functional programming techniques with TypeScript. So what that means is, rather than doing a deep dive into some of the more academic or highly mathematical parts of functional programming, I want to talk more on practical terms, so give you some hard examples that you can take away and then start using tomorrow. So how are we going to achieve this mission? Here's our agenda. We're going to start with a short overview of functional programming. Then we're going to talk a little bit about TypeScript and why it's useful, what we should do with it. Then we're going to get right into some code and look at some examples of functional programming with TypeScript. We'll finish off with a summary of what works, what doesn't, and then last of all, we'll talk about our next steps. So if any of this is interesting to you and you want to learn more, where can you take this next? All right, so functional programming, quick show of hands, who has attempted some form of functional programming before? And cool, that's good. And hands up if you're using functional programming every day in your day job. Yeah, a few hands. Nice, nice. All right. So let's get started. This is a little bit of a tongue-in-cheek diagram, but it's basically showing you that if you're coming from the imperative, object-oriented world, you're used to learning all of these patterns, all of these principles. In functional programming, it's slightly oversimplified here, but you're essentially working with functions. So you're breaking everything up into these small, reusable functions. So it's a change in mindset. Functional what? So we talk about functional programming. We also talk about functional languages. So it's good to make a distinction before we start. So if you look on the internet, if you Google what is functional programming, you will see a million different definitions, and it really depends on what type of languages people are using, what their backgrounds are. If they're really mathematical backgrounds, they'll have a different interpretation as to someone who's a more practical thinker. But one of the better definitions I have found is that functional programming is building software by composing pure functions, avoiding shared state, mutable data, and side effects. So functions are good, changing state and data bad. And what functional languages are enabling or enforcing the principles of functional programming. So the stricter a language is in enforcing these principles, then typically it's considered more functional or more pure. So we'll talk a little bit about what pure functional languages are a bit later. So where does functional programming come from? It draws a lot from the lambda calculus, which has been around since the 1920s, 1930s. Does anyone know who this young man with an amazing beard is? No? So this is John McCarthy, and if you do one thing after this talk, you should all go and look at who this man is and some of the achievements he had in his life. So he's influenced people like Steve Jobs, a lot of the Apple guys, but he's really interesting. So in 1960, he came up with a programming language called Lisp, and this is considered the first functional programming language. And a lot of the languages that we see today, for example, Clojure, these are also considered building upon this Lisp idea. So Lisp is actually standing for list programming. So since the 1960s, we've had a plethora of new functional languages. We've also had, in the last couple of years, a lot of buzz around functional programming in general. So we've got a million different blog posts telling you that you should learn one thing this year, and that's functional programming. We've got thousands of different people telling you or trying to explain to you what's a monad, how does a monad work, and we've got all these sort of heated debates about object-oriented is better, no, functional programming is better. So there's a lot of discussion, and if you basically forget all the buzz, don't worry about all the arguments, keeping in mind that functional programming still brings you a lot of benefits that you can still just start using and get those benefits straight away. So what are some of those concepts that bring those benefits? So these are just a few. So first off, we have the concept of first-class functions. So this means this language must treat its functions as first class. And what that means is that functions can be passed as arguments to other functions. It also means that functions can be returned by other functions. So we have a look here. We've got one example function as arguments. We're basically passing that in and executing. Then the other one is creating a function within its own scope and returning that. As you can see, many of you who write JavaScript will see that JavaScript does actually support first-class functions. What else have we got? Pure functions. So pure functions means you cannot cause any side effects. All of the change must be encapsulated within your function. You cannot share any of your state. And that given the same input and the same output, your function will always return the same value. So this is really useful for doing things like lazy evaluation, that sort of thing. So, and then I've just got a small little Haskell comic there, because everyone loves Haskell. All right, immutability. Hopefully everyone here knows about immutable objects, but for those of you who don't, basically it's constants everywhere. So once you create an object, you can't change its value. Again, that's it. And recursion. So functional programming doesn't have any loops, has no for loops. It uses recursion. So that means you're working with these higher order functions like map, filter. So a lot of you are probably already doing some functional programming in some sort by using these higher order functions today. And currying. So currying is another interesting concept. So this is basically taking a function which has many arguments, and you curry this, and then what you're given is a sequence of functions, each with one argument. So this allows you to create customized functions without having to define them. So it's still a little bit abstract. I've got an example coming on later that hopefully explains this in a bit more detail. And pattern matching. So pattern matching is a mechanism for checking a value against a certain pattern. So think of it as a switch statement on steroids. So you can see here the switch statement on the right and pattern matching on the left. It cleans it up. So this is a fairly trivial example. Some of the more interesting things you can do with pattern matching are also worth looking at. So what benefits do these bring? The first one, clean code. So you're working at a higher level of abstraction. So that means you're going to have less boilerplate code. You're going to have no class hierarchies, so it should be easier to read, easier to work with. And because you're breaking your code into these smaller sort of self-contained functions, it's easier to kind of follow what's going on, have a more understandable code base. Second to that, we are working with more and more complex systems as we go. So for example, we're dealing with a lot more concurrency, we're dealing with a lot more parallel processing, so not sharing state, using immutable objects. This really helps when you're working with a lot of concurrency. At the same time, we have these distributed systems, and these are really difficult to reason about. So if we're saying that we can't change state, and we have these small reusable functions, then it's kind of breaking these big complex problems up into smaller, more manageable pieces. And testing. So testing is another good one. So think about if you've got these small, again, self-contained functions. We have no external dependencies, no side effects. So that basically means the only thing you have to test is happening inside this function. So you're not mocking anything, you're not stubbing anything. It makes your testing much easier, much simpler. Next one, TypeScript. So TypeScript is a typed superset of JavaScript, which compiles to JavaScript. And what benefits does that bring? You get things like compile time error checking through using types. You get safer refactoring, especially when you're working with sort of larger code bases. It's easier and safer to refactor. You get documentation through your types, so you can more easily see what does this function expect as a parameter and what's it going to return me. As well as that, you get optional typing. So TypeScript uses or has the concept of type inference. So you don't actually have to define all of your arguments as types. It's clever enough to infer what these are. And lastly, it's a JavaScript superset, which means you can actually write JavaScript inside your TypeScript if you wanted to. Whether or not that's a good idea is another argument. And down the bottom here, we just have an interesting talk from Gary Bernhard, who gave a really sort of quick demo about some of the interesting behavior that you see or when working with JavaScript and trying to infer what types are. So this is Anders Harsberg. He's the creator of TypeScript. And this is a quote he gave about types in general. And I think this kind of shows that the approach that TypeScript takes when working with types. So it does give you benefits, but at the same time, you lose a bit of the flexibility of JavaScript. So it's important not to force people to be too strict, but at the same time, having that little bit of safety there gives you some nice benefits. All right, so we've talked about functional programming. We've talked about TypeScript. How do we go in combining those together? So we're going to do a quick code demo with a few examples. All right, so first off, we have two functions. Is that big enough for everyone? Yeah? OK, so we've got up the top, we have an untyped function. Down the bottom, we have a typed function. The only difference, as you will see, is the second function, we are annotating what our arguments are. So we're saying name should be a string, and would like sugar should be a boolean. And it's going to return us a string. We're not using any annotation in the untyped version, so we execute those in the same way. The benefit comes if, for example, somebody tries to call the untyped version, and instead of a name, they give a number. There's no kind of warning. There's nothing stated to the user. They think that's OK. And if we try and do that with the typed version, you'll see we get this little red compile time error, which is basically saying you can't assign a number to a string. So this is kind of just scratching the surface of the benefits that TypeScript brings you. The next one, recursion. So we have some simple objects here. We've got a customer type, which has a name and a list of beverages that customer likes. We've also got an array of these customers. So then we're creating a function, and we're going to get the name of all the customers who enjoy drinking coffee. So we can see if we did this in an iterative way, so using loops, we've got a lot of nesting. It's pretty difficult to find out what's going on here. And we've got a lot of cyclic complexity. If we try and do this instead with recursion, so we've broken it up into these three separate functions. The first one is basically calling filter and map. So it's grabbing these customers. First, it's filtering them using this isCoffeeDrinkers function. And then it's mapping them just to get the customer name. So the benefits with this is, for me, reading this, it's a lot clearer. I can test each of those individually, and it's just nicer code in general. If we look at the next one, immutability. So TypeScript has some inbuilt immutable objects, being the read-only. So we can make our customer read-only. So this type will then make the name and the beverages both read-only, and then we can look at the read-only array, And this also makes or provides us with a read-only array, which we can't, once we've created that array, we can't add any more objects to it. It's basically locked and immutable. So we can see down the bottom here, if we try and grab one of our customers and change his name to Bob, that's not going to happen. That's being prevented. And if we try and push a new customer into this array, we're also getting prevented there. All right, and next one, function composition. So function composition is the combination of two or more functions to provide you with a new function. So if we look at these three, in this example, we're working with a bank balance, and we want to basically transform that. So we're adding some salary, we're subtracting some fees, and we're subtracting some bills. So if we did this in a kind of traditional way, we can have our update bank balance function, which takes a balance, passes it to each of these functions individually, gets back the result, and assigns it. So this is doing some sort of bad no-no things in terms of functional programming. It's sharing state, it's mutating objects, and it's just generally messy. So we can also do this in here in subtract bills. We can get rid of this state mutation. We can get rid of this state mutation by nesting our functions, but I think everyone would agree here that that's not readable code. It's very difficult to understand what exactly is going on in this code. So instead, we are using a library here. We're using a functional library. It's called Ramda, if you look at our imports. So what this gives us is a pipe function. So we can pipe our data through these three separate functions. So we basically are given this update bank balance composed, and that accepts our data, passes it one by one through these functions, and then returns us the result. So there's no sharing of state. We get this nice, smooth data pipeline that we can then work with. So if I wanted to, for example, add another function into that, it would be super easy and super clean. All right, the next one, currying. So as promised, we have a function here still working with bank balances. So we have three arguments, the current balance, the salary, and the fees. And what we want to do is curry this function. So if we look, again, we're using Ramda. So what does currying let us do? It's transforming a function with many arguments into a sequence of functions, each with one argument. So first off, what do? We curry our original function here. That gives us back a curried function. And so this expects our arguments to be passed in one at a time. And each step of the process is going to give us back another function, which is expecting the remaining arguments. So if we look at the first one, update bank balance curried, we're giving it the current balance. That will give us back a function which still expects two of our arguments. We call that with the salary. And then the last one, we call it with the fees. So this gives us flexibility in when we provide our arguments. It also lets us, we could essentially pass these extra functions off to other parts of our code and use them there. It makes everything a lot more reusable and flexible. The last one is pattern matching. So I know we said we weren't going to talk about monads, but I lied. As you can see here, we're using a TS. It's called TS monad. It's a very simple Typescript monad library, and we're using what's called a maybe monad. So if you want a really simple, probably quite incorrect definition of a monad, here it goes. So if you think about values that you may be working with in your code, these values can have problems or quirks. So maybe a value is null. Maybe it throws an error. What monads do is try and deal with these quirks or problems by basically wrapping these in a container and then giving you these operations that you can then provide, that you can then perform on these values depending on what they end up being. So in this case, a maybe monad allows you to specify something that may or may not be there. So it could be a value, or it could be null, or it could be undefined. And functional programming uses monads a lot, especially when dealing with side effects. So these are things that you don't know what the end result's going to be, so you wrap it in a monad, essentially. So if you're coming from a JavaScript world, promises are a similar thing to monads in that you basically don't know what the response of something's going to be. It could be a success, it could be an error, so you wrap it in a promise. So what we have here, we have one function called can withdraw money. So that's taking a balance, and that's telling us whether or not this person is allowed to withdraw cash from their account. If the balance has a value, and if that balance is greater than 0, we can then say, yes, you can take some money out of your account. If we look at the pattern matching version, so we call a, sorry, just grab some water. We call our function in a similar way, but here we're wrapping our balance in a maybe, and so what that allows us to do is when we unwrap that balance, we can match it against just means yes, it does have a value, or nothing. So nothing means there was no value there, and so it's just a nicer API to work with, cleaner code. And again, this is quite a trivial example, but hopefully illustrates to you how you can then use pattern matching in your code. The last little thing I wanted to point out, if you do decide to kind of go down the TypeScript functional programming path, there's a super useful library, a super useful linting plugin for TypeScript called tslint immutable. And this gives you a bunch of rules you can use for ensuring that things are read-only, ensuring that you're not using variables, you're always using constants, you're not mutating objects. So this is super helpful if you're just getting started. And the second thing, if you're new to TypeScript, there are a lot of these extra static type checking options. So if you want to make your code super type, oh, that's good. Super type safe, then you can basically enable a lot of these too. All right. End of code. So, a summary. What have we learned? What works well with TypeScript and functional programming? What doesn't? The first thing, if you're new to functional programming, a lot of this terminology is scary. Monads, monoids, functors, category theory. So you read these, you start digging deeper, and then you're like, oh, my mind is blown. It's too much work. My advice would be you don't need to know all of these things to get started. It helps, but you can definitely get started and just try it. So the best way to learn something is to start writing code, start getting these sort of concepts into your head, and then over time, these more difficult things like monads will start making sense, and you'll start using them more. Types. As we said, type safety is nice, but it doesn't come for free. So the stricter you make people's lives, the more freedom they kind of lose. So you're trading off between safety of your code and dynamicness, so to speak. The other thing that's worth mentioning, if you're coming to TypeScript with a functional programming mindset, a lot of the sort of JavaScript libraries that are working with TypeScript can have some interesting quirks in the types that they offer. So Ramda, for example, is one of those. What else have we got? So pure functions, easy to write, hard to combine. So writing these small self-contained functions is kind of the easy part. The more difficult part is composing these together into a program which runs, which makes sense, which you understand. So this is changing the mindset from kind of an imperative programming world to more of a declarative. So getting those changes and understanding what the best way to structure something in a functional world takes some time. But yeah, stick with it. It comes after time. And yes, side effects. So we're all, I assume, working with something to do with the web. So the web involves writing to the console, writing to files, databases. All of these things are considered side effects in the functional programming space. So how do we deal with that without making our lives an absolute nightmare? And yeah, this is basically a diagram taken from sort of the Scala approach. It's basically keep all of your core logic, your core business logic can be functional, and then try and isolate anything that's having side effects. Try and keep those two separate, and then managing those separately will make your lives a bit easier. And higher kind of types. So you can think of these as generics. These are common in typed functional languages like Haskell and Scala, and they're really important if you want to be using things like monads and monoids. TypeScript does not have higher kinded types yet, does not support them. This causes a few issues sort of following the pure functional programming mindset. There's a few open discussions, but nothing is kind of, no short-term solution looks to be on the cards. All right, so next steps. So if you're interested in this and you want to sort of learn more or dig deeper, how do you go about your functional evolution? So as I've stressed the whole time, it's a journey. It's something that takes a bit of time. If you're coming from an object-oriented world and you start writing functional code, the first thing you're going to write is basically imperative code in a functional style. And don't be put off. Like the pure kind of functional purists will not like your code, but then stick with it. You'll get better over time, and you will make that evolution. These are a few TypeScript libraries which are dealing with functional constructs. So if you want to dig deeper into the very academic, the very mathematical parts of functional TypeScript, this G. Canti, the first link, is an Italian guy, and he's been doing a massive amount of work trying to get functional programming into TypeScript. True myth is also an interesting thing to look at. Then we have some immutable data structures, and yeah, this pure algebraic data types are also fun to play with. Then these are some functional JavaScript libraries which have TypeScript typing, so they're supported in TypeScript. Ramda is a few of the examples we saw already. Sanctuary and Folktail are also really good functional libraries. Folktail is in the middle of kind of converting their code base to TypeScript. Immutable.js, I'm sure most of you have heard of from Facebook. And then if you're coming from like a Scala world or dealing with futures, Fluture is also quite cool. So maybe you want to take it one step further. Maybe you want to jump out of TypeScript and JavaScript completely. So these are some additional languages, some functional languages which all compile to JavaScript. So Elm is super interesting language. It's been around for a few years now. It's heavily influenced by Haskell. The documentation's great, and the debugging experience is also really helpful. PureScript is one of the new kids on the block. And then we have Reason, which is from Facebook, and that's writing OCaml, which then compiles into JavaScript. Idris is another one, so if you're interested in more Haskell-styled languages which compile to JavaScript, this is one I'd recommend. Scala.js, ClojureScript, this is Scala and ClojureScript both compiling to JavaScript. Fable is F#. And then if you really want to go hardcore, you can check out GHC.js, which is the Haskell compiler to JavaScript. So that's it. I hope you got something out of today. If you want to sort of chat and dig deeper into any of this, I'll be at the BCG DV booth until the end of the day. But yeah, enjoy the rest of your conference.
We did have some great questions, one of which I think was briefly sort of alluded to in your second last slide. It was, what do you think of Flow.js? You talked about everything but.
No, I think it's also it's a good alternative to TypeScript. So they're similar kind of goals, I think. I haven't looked at it in as much depth as I have TypeScript, but they're kind of competing subjects. I know so these higher kind of types that I spoke about, which kind of restrict some of the functionalness of a language, the Flow is also dealing with this and trying to solve that problem as well. So they're both kind of in similar positions.
All right. Now, that was the easy one. The next one, I have a feeling, is one of these ones that is better asked in a pub or other place where people bicker about things.
Yeah.
And the question was...
It's an opinion one then, right?
It's one that requests your opinion.
OK.
And that is, with WebAssembly going GA...
What's what? Sorry?
WebAssembly, compiled sort of to the lower edge of the browser.
I know where this is going, yes.
Yeah.
Should you use TypeScript, or does TypeScript make sense?
Why not just go direct to Haskell and so on and so forth, which you kind of touched on again by talking about JCJS.
Yep.
What is your thought about where this might take functional programming?
Yeah, it's an interesting question. I think the problem TypeScript has with trying to approach this kind of functional programming paradigm and being as pure and as functional as possible, it means it has to kind of change a lot of its design principles, which is about keeping a little bit of flexibility and that dynamicness of JavaScript. So will functional TypeScript ever be something that is sort of worthwhile? I'm not sure. It certainly has its benefits at the moment, but yeah, there's a lot of other good approaches as well. So if I was tomorrow to start a new project and wanted to do it in a functional style, would I use this? Probably, it depends on the problem you're trying to solve, how technical and meaty it is. But there's other good options like Elm, Purefying are also more functional and more following the strict functional.
I've got to say, I personally don't know. I could see arguments both ways. I know historically, our industry has tended to favor things that look like whatever we were using 5 years ago. We still have curly braces in a lot of languages. Yeah. We still have things. There's a certain obvious inertia towards, oh, this looks familiar. So things that look a little like JavaScript probably have an appeal. Yeah. However, this is a domain where a more pure language and with higher kind of types and other things deliver some benefits. So I don't know.
Yeah, I would say that this is, if you've never written sort of functional worked with functional languages before, this is kind of a good thing to put your toe in the water, see how it is, because it's not as strict as something like Haskell or Elm, for example. So you can kind of play around with these concepts without getting kind of slapped in the back of the head when you do something wrong.
Fantastic. Folks, what do you think of his talk? Thank you so much.
Thank you.